Okay, we're looking at the second year Stats and Mechanics textbook, and we are on exercise 6, which is on projectiles, looking at chapter 6, and we're looking at exercise 6D, which is on projectile formulae. Okay, so question 7, so it's an exam question, so we can see the mark allocation, and it's also problem solving, so we're going to have to think carefully about how we can tackle this. Okay. Right, so let's look at the first bit. Okay, so they're describing a situation here. It's a volleyball game, so the ball is not starting at ground level. It's starting 1.5 meters above the ground and moves in a vertical plane which is perpendicular to the net. So this is the net here, and then this is the path of the ball. Okay, so by writing down expressions for the horizontal and vertical distances. So let's sketch out, let's get that out of the way. Okay, so let's do our own quick sketch of what's going on. So the ball is starting 1.5 meters in the air and it's traveling like that. There's the ground. Let's label on some distances. So that's 1.5 meters. They're calling an angle of alpha, they're using it, alpha, and the initial velocity at an angle of alpha is u, or initial speed of u meters per second. Okay, so let's think about distances. So let's go horizontally first, because that's pretty much always the easier way to go. So let's cover that up. Okay, so because we don't have any acceleration in the horizontal direction. So what do I know horizontally? Well, I know that the initial horizontal velocity, so that component of the velocity is going to be capital U, and that's adjacent to angle alpha, so that's going to be U cos alpha. I'm going to call time t, okay, because that, as we've seen in the previous questions, it's the time that's going to be the same whether I'm looking horizontally or vertically, and they're asking me about the displacement, so I'm going to call that x in the horizontal direction. Okay. So, and as we said, acceleration in the horizontal direction is going to be 0 as far as we're concerned. So I could use a Q7a equation, or I can just use that displacement is going to be velocity times time, and because there's no acceleration, the horizontal velocity is going to be constant, so the horizontal velocity will be u cos alpha throughout its entire journey. Oh, let me do that. That's right. Okay, so just using that, so displacement in the horizontal direction I'm calling x. The velocity is a constant u cos alpha times time. Okay, so, and then we will come back to that. But that's what they asked me to do in the question. That was the hint they gave me. They said, I write down expressions for the horizontal and vertical distances. They gave me a bit of a clue as to how on earth I'm going to end up with this. Okay, so let's go vertically. Hopefully I've left myself enough space. So vertically, the initial velocity, so I'm looking for that component of the initial velocity. So obviously we've got a right angle triangle there. So that's opposite angle alpha, so that's going to be u sine alpha. T, I'm just calling t, and there is acceleration, so I'm taking up as positive. There I was taking right as positive. So if I'm taking up as positive, acceleration is going to be minus g, because obviously gravity works downwards, and I want an expression for the displacement. So I am going to use S equals ut plus a half at squared. So S in the vertical direction, I'm calling y. The initial velocity in the vertical direction is u sine alpha. T is just t. Plus a half a. So a is minus g, so that will become minus a half g t squared. And there, just really matter, it's a different colour. There's my expression for the vertical displacement. Okay, so that's what it asked me to do. So this question is actually a bit nicer than some of the previous ones because it did give me a hint in how to get started. So then they want me to come up with this equation here, and this is in terms of capital U and alpha, but there's no t in there. So what I am going to do is eliminate t and then have a think about, they don't have x and y either, but we'll come on to that next. Okay, so obviously this one is the simpler equation. So I'm going to make t the subject of this one. And then I'm going to substitute that into this equation. So wherever it says t, I'm going to substitute in x over u cos alpha. Then we'll take stock of what we've got. So that's going to become y equals capital U sine alpha. And then for t, I'm going to substitute in x over u cos alpha minus a half g. And where it says t, again, I'm going to substitute in x over u cos alpha, and that's all squared. Okay, right, so let's see if what we've got looks remotely similar to what they've got. Yeah, so some of it I think is looking okay. So get this on the same screen. No, I can't, but I've got, well, okay, so let's simplify what we've got first. So what can I do here? Well, that u and that u can cancel. So I'm left with x, and then I've got sine alpha over cos alpha, which is tan alpha. So I've got the tan alpha they wanted. If I square out these brackets, so I've got g, and then that will be x squared. I've got the half, and then that will be u squared and cos theta squared. Okay, so let's go back to, let's put that up to the top and see how that compares to what we want. Okay, so I've obviously got the tan alpha, I've got the u squared, and I've got the cos squared. I've got g, but there's no x and y. So if I read back through the question and see if I can substitute in, see if they give me a specific point, and they do, because they tell me that the ball just passes over the top of the net. So basically they're telling me, so I think I just need to be careful with what I use for y. So at this point here, the ball has travelled 9 meters along. So it's travelled 9 meters in the x direction. It hasn't travelled 2.4 meters in the y direction because it didn't start down here. It started at 1.5 meters. So in terms of how far up it's actually travelled, I'm going to do 2.5 take away, sorry, I'm going to do 2.4 take away 1.5. And then that's starting to look quite good because that gives me more of an idea of where the 9, the 81, well, I've got an x squared there, and the 0.9 are going to come from. Okay, so they're making this work for our 6 marks for this question. So, so just using those two values, y is 0.9, x is 9, and then looking at the numerator of this fraction, so x squared is going to be 81, and then that's just going to stay as it is, and we will double check, but I think that's what they wanted us to get. Double check that fraction's all okay. Yeah, we've got exactly the same fraction. The only thing I think once I've done this question, I would probably, in hindsight, want to add in is I think I would just, because I didn't put it on my diagram, be clear where I got those from, because it might look like I just spotted, oh, well, look, they've got a 9 and a 0.9 in their version, so I'll use those values. So I might just say, just to make it really crystal clear, I'm not fudging it, 2 point, just something to be really clear that I do know what I'm talking about.